All right, let's get started. Today, we're going to look at a farm field a little differently. Not just as a plot of land, but more like a patient. We're going on a full diagnostic journey to understand its health, figure out what's wrong, and ultimately write the perfect prescription to make it thrive.
I mean, just look at this picture. It's one field, right? But you can see all these wild differences across it. Patches of green, patches of yellow, different textures. This is the heart of the problem we're tackling. If the field isn't uniform, why on earth would we treat it with a uniform plan? That's kind of like a doctor giving every patient in the hospital the exact same pill no matter what's wrong with them. It just doesn't work. And in farming, what doesn't work? Well, it costs you.
So our first step is to just acknowledge the symptom. We're dealing with an uneven field. We're moving past this old idea that a field is just one big, consistent block. No way. It's a complex system, full of variations. And if we want to manage it well, we need to get smarter and treat the different parts differently. And our thinking on this has really evolved over the years. We started with what you'd call uniform management, one soil sample for the whole field, one fertilizer rate across the board. Simple. Then we got a little more sophisticated with management classes, breaking the field into a few big zones, maybe a good spot, a bad spot, and an okay spot. But where we are now, that's site-specific management. We're using data, and a lot of it, to create these incredibly detailed, high-res plans for every square foot of the field. It's all about putting inputs exactly where they need to go.
Okay, so that brings us to the examination. We know the field has issues. We know it's variable. But how do we actually see what's going on under the surface? How do we map those unseen forces? This is where we got to choose the right diagnostic tools for the job.
And here are our main options. On one hand, you've got grid sampling. It's super thorough, gives you even coverage, but wow, it is expensive and a ton of work. On the complete other end of the spectrum is the old whole field composite. Yeah, it's cheap and easy, but it totally ignores all that variability we just talked about. It averages everything out to meaninglessness. For a lot of people, the sweet spot, the real winner, is zone sampling. It's just smarter. It's targeted, efficient, and uses data to get the job done right.
Which, of course, leads to the big question, right? If zone sampling is so great, how do we actually create those zones? I mean, where do you draw the lines?
Well, a lot of the time, it starts with data you probably already have. Take a look at this map. This is showing sorghum yield. The blue spots are killing it, high yields. The orange and red spots, not so much. These patterns aren't just random, they're clues. They're telling a story about what's happening in the soil. That blue area might be nutrient-rich, while that red area is crying out for help. This is how we start to build intelligent zones.
But you know what? It doesn't always have to be about fancy technology. Decades of walking a field, feeling the soil under your boots, that's a powerful data source too. On the left here is a hand-drawn mud map. A farmer literally sketched out what they know to be the high, medium, and low zones. And on the right, that map is being used to guide a really precise sampling plan. It's this beautiful blend of old-school wisdom and modern science.
Okay, now let's get our hands dirty and talk about the procedure. Because let me tell you, all the best maps and data in the world mean absolutely nothing if the sample you send to the lab is garbage. A good diagnosis absolutely depends on a good sample. There's a real art to it.
And the tools themselves aren't super complicated. We're talking about soil probes, augers, things like that. The goal here isn't to be fancy, it's to be consistent. You need to get it clean, vertical core from the right depth every single time. If you don't, your results are going to be all over the place.
So here's how you do it right. When you're in a zone, first, you got to clear away any leaves or junk on the surface. Then, take a nice clean slice of soil down to about 6 or 8 inches. Now, here's the most important part. You don't just do this once. You do it at least 12 to 15 times randomly all over that zone. All those little cores go into a clean bucket, you mix them up really well, and that becomes your one composite sample that represents that whole area. And hey, just as important as what to do is what not to do. Stay away from weird spots. Don't sample right up against a road or a fence line. Avoid that one wet spot where water always pools, or that spot where an old manure pile used to be. Those aren't typical of the whole zone. And please never mix soils that look and feel totally different. If you see a change from sandy to clay, that needs to be a separate sample, period.
Now, a soil test is fantastic. It tells us what nutrients are available for the plant, but it doesn't tell us what the plant is actually using. For that, we need a second opinion. We've got to go straight to the patient, the plant itself, and basically ask it, hey, how are you feeling? And that's exactly what plant tissue analysis is.
When we get those plant tissue results back, this is the single most important concept we're looking for, the critical concentration.
Just think of it as the tipping point. It's that line between enough and not enough. If a nutrient is below this level, the plant is struggling and your yield is going to take a hit. It's the benchmark that turns all those lab numbers into a real, actionable diagnosis.
And that critical level fits into this whole spectrum of nutrition. You can be deficient, where the plant is obviously sick. You can be right at that critical threshold. Or you can be sufficient, which is our target, the sweet spot. But then it gets interesting. You can have luxury consumption. This is where the plant is just sucking up extra nutrients it doesn't even need. It doesn't help your yield one bit, which means you literally paid for fertilizer that's doing nothing. And at the far end, you can actually hit toxic levels, where too much of a good thing starts to hurt the plant.
Okay, let's pull all of this together. We've examined our patient, we've run the labs on both the soil and the plants. Now it's time to sit down, look at the charts, and write the prescription. It's time for the final diagnosis and the treatment plan.
And you know what? At its heart, the math is actually really simple. First, you figure out what your crop needs to hit its yield goal. Think of it as the crop's appetite. Then you look at your soil test and see what the soil can already provide, what's already on the menu. The difference between those two numbers, that's what you need to apply. It's just a simple balance sheet. Crop need minus soil supply equals your fertilizer rate. That's it.
Look, this whole diagnostic process, from start to finish, is about one thing. It's about shifting from guessing to knowing. The patterns in the field, the chemistry in the soil, the health of the plant itself, it's all data. Your field is talking to you. It's telling you exactly what it needs to perform at its peak. So the only real question is, are you listening?